Okay, let's give you guys some practice. So determine if this series will converge or if it will diverge. The hard part is in deciding which test to use. Well, anyway, press pause and have a go. Okay, so to do this, the hard part is in deciding which test to use. Well, you should always perform this test first. If you're trying to investigate a series, well, compute this value here. Compute this thing as n heads towards infinity. So this is what we're trying to investigate. We should compute this thing here. We should compute this thing here as n heads towards infinity. So now as n heads towards infinity, the numerator will be heading towards infinity because natural log looks like this. As n heads towards infinity, it's just going to, the numerator is just going to get bigger and bigger and bigger. The denominator, as n heads towards infinity, the denominator will also head towards infinity. So here you've got infinity over infinity, which means you can use L'Hopital's rule. Well, infinity over infinity is an indeterminate form, so you can use L'Hopital's rule. But before you can do that, you have to map a function on top of this, because at the moment n is discrete. N is 1, 2, 3, 4, 5, and so on. N is discrete. Well, we want to map a continuous function on top of this. So now turn this into a continuous function. So this is now a continuous function. So we can use L'Hopital's rule. So using L'Hopital's rule, we can then differentiate the top, and then differentiate the bottom. That will then give us this, and then now tidy this thing up. That will then give you this, and then as x heads towards infinity, the numerator will act as x. This will act as x. So the limit will be 1. So the limit will be 1. Now if so when you perform the nth term test, if the limit is not 0, then you can be 100% sure that this will diverge. Because in order for something to converge, you have to be heading towards 0. You have to be heading towards 0. Anything other than 0 is going to diverge. Because even if, suppose the limit is 0.007, say, then it's still going to diverge. Because if you think about it, if the limit, if your sequence is looking something like this, and this level here is 0.007, then by the time you get to, let's say here, you're adding this amount to your whole summation, and then here you're adding an extra amount. Here you're adding an extra amount. Here you're adding an extra amount. You keep on adding an amount to it, so eventually it's just going to get bigger and bigger and bigger. It's going to diverge. If it has to head towards 0 in order for it to converge. Okay.